Hi, we meet again at part 2 on chapter 2. So in this part of chapter 2, we're going to describe the projectile motion launched at an angle theta as well as a special case when the angle is 0 and 90 degrees. So in these simulations, you can see a game of Angry Birds that once been so viral that everyone played the game. In this game, you can see that the birds try to strike one of his friend onto the target to demolish it. So this is a part of the concepts of projectile motion where the birds take parabolic paths. The patterns form is called the parabolic path. So what is the projectile motion? So in this case, we can see a player playing a football. So he tried to kick a ball and the ball goes a pattern. The shape pattern is in a shape of we call a parabolic path. And we can see that few points along the parabolic path, taking the first point, that is the initial position. The velocity component is along the line of parabolic path. And the second point, written as V1, it is at a certain angle of theta 1. And the third point is at a maximum point, it's called the V2. So the velocity take no angle, theta is 0. And the fourth point, V3, the angle is written as theta 2, and the last point as the V4. So the object is kicked or hit or thrown with the angle will shows a parabolic path. So this is the trajectory taken by the football. So we can focus on the components of velocities on each of the 5 points given. So in this point, the first point is point A. So what happened at point A? So at point A, the velocity component is written as ux or uy, just like in chapter 1. So ux is the components of velocities along x component, and uy is the velocity of y component along the y-axis. We can focus that the velocities are varies for the y component, meaning that at point A, the u is longer compared to the v1y at point P. And at point B, which is at maximum height, there is no v at all. There is no vy at all. Okay, and at Q, it seems like the velocity is pointing downward as v2y. And at point C, the velocity is longer along the y component compared to the point Q. So all these 5 points shows that the velocities along y components are changing. Okay, so since the velocities along y components are changing, we can say that the acceleration presents. So the acceleration is ay influenced by the gravitational accelerations of the Earth, which is g. But since the acceleration is pointing downward, so we must put a sign conventions minus. So ay is a minus g. And think about the velocities along the x component. So at point A, the velocities along x component is written as ux, pointing to the right. And at point P, it seems like the vx, v1x is the same length as the ux. And at point B, the x components of velocities is v, also the same length as ux and v1x. The same goes to the point Q, v2x the same as the vx at point B, v1x at point P, and the ux at point A. And the last point C, the same thing happened. The v components x at point C is the same. So we can see that all these points, the x components of velocities are all constant. So there's no changes of velocities along the x component. It means there is no accelerations at all present along x component. So ax become 0. So this is the basic concepts of projectile motion that you must know. Let me summarize that, meaning that for projectile motion, the velocities along y components varies, giving acceleration ay is equal to minus g. And the second concept is the velocity along the x components are constant, giving no accelerations along x component. Right, so next part, we're going to do the horizontal projectile motion. The concept is a bit similar to the normal projectile motion. The only difference is that you can see the simulation where a bomb is tried to be dropped from a plane. So the plane dropped the bomb. And what happened to the bomb? So you can observe that the bomb tried to take a parabolic path, but it starts from the maximum height. So at the maximum height, Vy is equal to 0, just like the concept for projectile motion. So there is no y components of velocities at the initial position. So Uy equal to 0. And as it follows the trajectory, which is a parabolic path, the components of Vy is slowly increasing. So from 0, it's slowly increasing to a certain magnitude values of velocities until it reaches the ground, which is at point B. That is what happened to the velocities along y component. So since velocities along the y components are varies, it makes the accelerations along y components present. So in this case, ay is equal with minus g, because it is the bomb dropped by influence of the gravitational acceleration of the Earth, minus g. So that's the concept for y components of velocities and the acceleration. Okay, the second part is the velocities for x component. So starting from the initial position, the velocity is written as u. Okay, this is the maximum velocity u. As it follows the trajectory of parabolic path, it seems that all these velocities along x components are constant, the same like the normal projectile motion. So as it goes along the parabolic path until it reaches point B, the velocities along x component are constant. Vx equal to u. So practically there is no changes of velocities for x component, giving acceleration along x will be 0. So ax is 0 because no changes of velocities. Velocities along x is constant. So the third quantity we can see from the picture is the vertical displacement, which is written as sy. Sy or also as h. H is height. And the fourth one is the horizontal displacement as x, as written as x, or we can say as range. This is horizontal range. Right, so the third part of chapter 2 is the free fall motion. So in this simulation, you can see two objects. One is the stone and the second is the feather. So one of these objects affects the free falling motion, which is the stone, because the stone has almost no air resistance. But on the feather, as it falls down the building, there is lots of air resistance acted on the feather. It slows down the drop feather. So what's the free falling motion? So the free falling motion is a motion, a vertical motion under gravitational field without the air resistance. So if air resistance presents in our example, so we didn't call that as a free falling body. And what's the value of the constant acceleration is given as 9.81 meter per second square. Just maybe forget about what you learned during the school, that G as 10 meter per second square or 9 meter per second square. So in matriculation, we're going to use the exact value of the G, which is 9.81 meter per second square. So in conclusion, the free-falling body is a body which undergoes constant acceleration, which is 9.81, without the air resistance. Okay, this is the examples of a ball being thrown straight up. So it's just not the matter with the ball falls down. So if the ball thrown straight up 90 degrees from the ground, we can say that as a free-falling motion as well, because the angle mix is 90 degrees. So as the object moves up, you can think about the velocities along the y component. Maybe you can, anything you hold on your hand, except your phone, you can hold anything, any object. Take any object, maybe an eraser. Don't take your phone because everything is expensive nowadays. You can pick an object, okay, and then try to throw the object straight up, and observe what happened to the velocity as it goes up. So what happened? Yes, the velocity is decreasing, so it slows down. So the object that you throw from your hand slows down as it reaches the maximum height. So since this velocity is slowing down or decreasing, meaning that there must be acceleration present along the y component. This is affected by the gravitational acceleration because we are on the Earth. As long as we are on the Earth, we can't fly and floating around. So then we are pulling towards the center of the Earth. So it is influenced by the gravitational accelerations of the Earth, which is 9.81 meter per second square. So that's why the velocity of the object that throw from your hands are decreasing. And think about what happened when the object that you throw reaches the maximum height. Yes, it will momentarily stop. It will stop for a moment, just maybe 0.001 second or milliseconds. Just stop for a while. Because why? Because it tried to goes back down to the ground. So as it goes back down to the ground, the velocity is slowly speed up. So it takes up velocities. So it's speeding. From the maximum height reaches the ground, it's speeding. So velocity is increasing. So again, since the velocity is increasing, meaning that accelerations along y components also present, which is equal to the minus 9.81 meter per second square. So these two parts are the explanations for the object free-falling body motion goes up and goes down. And the last part that I'm gonna use to focus is at the maximum height. So I've mentioned that at the maximum height, the ball momentarily stops. So makes the velocity equal to 0. So since velocity is 0, what happened to the acceleration? Does the acceleration at the maximum height also equal to 0? Or it doesn't? Yes. So acceleration along the path, doesn't matter that wherever it is, as long as it's along the path, acceleration also presents is which equal to minus g, minus 9.81. So at the maximum height, even though the velocity is equal to 0, the acceleration of the y component is also minus g. We can't say the acceleration is 0 because of velocity is 0. Because if acceleration is 0 at the maximum height, the ball will floating. It doesn't make any sense at all, because when you throw something up in the air, it will drop. So it can't just floating by magically hang there. So it doesn't logic at all. So it will drop. So that's why AY is also minus G at the maximum height, even though the velocity is 0. Right, that's it for the free-falling motion. So I'm gonna leave you with one questions. Okay, read through the exercise 1. Okay, so the question reads as a ball is thrown straight up. Make a statement about the velocity and the acceleration when the ball reaches the highest point. So I just mentioned in the examples of the stone that thrown straight up. So A, B, C, and D. Read through the answers and pick your best answer. A, B, C, or D. Yes, correct. The answer for exercise 1 is B. I congratulate to all of you that answers B. So the answer is velocity is 0 and the acceleration is not 0. A is wrong because it mentioned acceleration is 0. So A is wrong. If acceleration is 0, the ball will floating in the air. So that's wrong. C, velocity is not 0. No. What happens if the velocity is not 0? So what will happen is if you throw a ball and it will goes up into the sky. So you have a superpower. Do you have a superpower to do that? No, you don't. So velocity is 0 at the maximum height. So C is wrong. And D, neither velocities nor acceleration is 0. This is obviously wrong. So the answer is B. So that's it for chapter 2. We're going to meet again at the chapter 3 of momentum and impulse.